Hello, and welcome to the last session of Android Dev Summit, or the ultimate session, I think, which is called Get Animated. My name is Nick Butcher. I am a designer and engineer here at Google.
My name is Doris, and I work on the Android UI Toolkit team. I'm responsible for Android Animation API.
And I'm Nicolas Roard. I'm working on the design tools on Android Studio as well as on ConstraintLayout.
John Hoford, working on ConstraintLayout, MotionLayout, and design tools.
Great, so let's get started. So Android has always had animation APIs. The number of APIs has grown as the system has grown and become kind of more fully featured. There are a variety of different APIs for different situations that have been added over the different API releases, as well as to the new support libraries like Android X. But sometimes we hear that the variety, the range of animation systems can be overwhelming, that you don't know which one to reach for or which is the best for a certain use case. So our goal today is to really give you an overview of the different animation systems, tell you what they're good for, what they might not be good for, and give you the confidence to know which to reach for when you need to achieve something. And we're going to spend a bit of extra time on the new hotness that is MotionLayout today as well. So let's dive right in. First up is Android's oldest and original animation API, which was Android View Animation. I would urge you to kind of consider it deprecated. Unfortunately, it's not actually app-deprecated, as I'll get to in a minute, but maybe just think of it in that way. So this, like I say, an older animation API was kind of runs in a certain phase of the view system. So as everyone knows, most views have like a measure, layout, and a draw. Unfortunately, because the animations only run in the draw pass, it means that we can't do certain things like deferring rendering when we don't need to. And it also leads to certain things where, because the animation is only applied in the draw pass, you don't know maybe what it looks like is somewhere in your layout. Maybe you've animated the button to a certain position. When you try and press it, the view's bounds haven't actually changed. It only exists within the view system, the drawing pass system. So it can lead to a bunch of different problems. Basically, it's been considered deprecated because it has much, much better replacements. It belongs in a museum. Hey. I'd say deprecated, except there are actually, well, one single use case I can think of where you still have to use it. And that is when you're doing window animations. So when you're doing window animations when a new activity launches, then this API only accepts this type of window animation because it existed from API 1. But also because these window animations have to declaratively state all the information to perform the animation. The fact that it runs in the draw pass is useful because it guarantees that the view is already measured when you do this. And that allows it to define certain things like here we're seeing like a Y delta animation, which means 10% of the Y position. So because it's already definitely guaranteed to be measured, this can be useful. The only other place you might need to use it is if you're doing fragment transactions. So here, when you set the animations to run a fragment transaction, you can supply this Android View animation as an arg, but the API also accepts the newer Android Animator. So I urge you to kind of use the newer one if you can. So that was View Animations. Basically, only really use it for window animations, or if you really, really have to, if you need to rely on that measured size part for a fragment animation. Otherwise, think it's deprecated. Next up, Animator.
All right. Wait, didn't change. Oops. All right. So Nick has just talked about a view animation. Now let's take a look at the Animator, the new Animator API that was introduced in API 11. So the new Animator API is much more versatile than the view animation because it allows you to animate more than just view properties. You can essentially use it to animate any arbitrary property on any object. And then you can even just animate any value, not necessarily associated with any property at all, using the Value Animator API. And since the introduction of the Animator, we've built a bunch of higher-level animation constructs on top of the Animator, such as Animator Vector Drawable, Animator Stateless Drawable, Transition, and the default item animator in Recycler View. And people always ask me, between animation and animator, which animation API should I use? And the answer is definitely the Animator API, because it's just much more capable. And in this section, we're going to look at a few animators. We're going to look at value animators, where you can animate a value. And we're going to look at ObjectAnimator, which not only animates the value, but also automatically sets that value on a property. We're also going to look at animator set. And then we're also going to take a look at the view property animator. It is not an animator, but it's backed by a value animator. We'll talk a little bit more about that in a minute. And then also, we're going to look at property values holder, which you can use in conjunction with value animator. So here's an interesting animation with a little juggling man. And that can be achieved with the Animator Drawable, which Nick will talk about in the next section. Or you can use Lottie for it. But now let's look past that. And on top of this little man, there are texts being animated in and out. So in order to achieve that, we can just simply create an ObjectAnimator to animate the alpha property of this view. Pretty straightforward. Notice how here I'm supplying an alpha string. And that is a bad idea. Because when the property string is being passed to the ObjectAnimator, what we're going to do is we have to prefix that string with the set and get in order to then use reflection to find the setter and getter in the target objects class. And that's inherently more costly. What we recommend instead is using this view.alpha property object. It is introduced in API 14, along with a bunch of other property objects for other view properties. What happens in this view.alpha is that whenever the animation value gets updated, the set value will be called. And then from there, the set alpha will be called on the view. So that's one level of indirection, much more efficient than reflection. If we take a closer look at this animation, we can see that no text not only animates in, but also it blows up. So there are three things going on, three properties being animated: the alpha, scale x, and scale y. Here's how we can do that with property values holder. We can create 3 property value holders, 1 for each property, and then we can specify the start value and the end value for each of the property. And once we have all these property values holders defined, we can then set these property values holder on the ObjectAnimator. So then the ObjectAnimator can then drive the change of the property values. And one caveat is when you use multiple property value holders on one ObjectAnimator, you are essentially animating all these properties with the same interpolator, using the same duration on the same target object. But a lot of times, when you want to animate scale x and scale y simultaneously, that's exactly what you need. And if you want to define that same ObjectAnimator in XML with the property values holders, it looks pretty straightforward. Now, if you take a look at the bottom of this animation, there's that button fading in after all the text animations have finished. To coordinate these different animations together, we can just create an animator set, and then with the play method, it would return an animator set builder, and we want to play the fade in after the fade out. And then while the text is fading in, we also want to blow it up. So we're going to play the fade in with the scale animation. And then we want to play all the text animations before the button fades in. So that's pretty straightforward API and powerful too. Now, we've seen how we can animate various properties using property values holders in conjunction with ObjectAnimator. And if these properties that you're animating happen to be view properties, here's a more straightforward way to animate them. You can just call view.animate. That would create a view property animator. And then there are a bunch of methods for various properties, and then you set an end value for these properties. And then optionally, you can set an interpolator and start. This is the syntax for view property animator. It doesn't get more beautiful and concise than this. And view property is backed by a a value animator, it's not an animator. So you can't really coordinate it with the other types of animators. You also can't reverse it or seek it or repeat it. Some people ask me, is view property animator as efficient as ObjectAnimator? I can assure you it's actually slightly more efficient than ObjectAnimator. The reason for that is view property animator has been optimized for animating view properties. And as a result, it ensures that for all the view properties that you're animating, there's only one pass of invalidation gets triggered per frame. Whereas if you use ObjectAnimator to animate various properties, then each property change is going to trigger its own set of invalidation pass. View property animator is more for a fire and forget kind of use case where you just start the animation and just forget about it. Now, you might have seen this animation before in the previous slides. Did you notice that there's 3 little dots animating at the end of the text? And since these 3 little dots are not really a property for the text view, so here we're going to create a value animator to animate the number of dots. We're going to create a value animator of integer type to animate from 0 to 4, and once it gets to 4, it will then wrap around and restart at 0 because there's a repeat count. And with value animator, you almost always want to use an update listener because value animator is just going to animate on its own. It has no impact to anything outside of it. So here, with the update listener, we're going to read the value out of the value animator and use it as the number of dots that we want to show. And then we're going to have a spannable string from the text view. We're going to set a span for we're going to set a transparent foreground color span on this text, on the dots that shouldn't be showing. And which, with each animation update, we would update the number of dots that should be showing, and then correspondingly change the range to hide the dots that we want to not show. So to recap, when should we use what kind of animator? ObjectAnimator is kind of this all-purpose animator that, as long as you have a property you want to animate, you can use that. Value animator is for animating a more customized kind of animation where you want to animate this value, and then you want to then use that value to apply to something else in your UI. And the view property animator is best used when you have multiple view properties that you need to animate simultaneously on the same view. And because you can't really coordinate this view property animator with anything else, it's only good for the fire and forget use case. And then property values holder. With property values holder, you can define multiple properties and then animate them using an object animator. The nice thing about property values holder compared to view property animator is that it not only allows you to animate multiple properties simultaneously because it's really being set on the object animator, you can then coordinate that or seek and reverse. So it's more powerful. And then animator set, when you have multiple animations that you want to coordinate, animator set would be a good choice.
Thank you very much. Next up, we've got animated vector drawable. So these are great for doing vector graphic animations like these wonderful little icons you see in the new Google Fit application. Animated vector drawable is actually a very thin wrapper around 2 more powerful things. It basically connects together a vector drawable to one or multiple object animators and runs animations on them. It has a very small, focused API. It basically implements the animatable interface, which is basically just lets you play, pause, and stop the animation. So you can get an animated vector drawable like this and just call start. AVD is great for like performance-critical kind of vector graphic animation, especially from Nougat onwards, where animated vector drawable was re-implemented in native code and also offloaded to the render thread, which means that even if you're janking the UI thread, and you're not doing that right, that your animation will keep on playing. But it also means that there's just more time on the thread for you to do your code rather than running the animation code. So when to use animated vector drawable? So when you need to animated icons or animated vector graphics. When it needs to be this fire and forget. Because it has that simple API that just start and stop, you can't seek through it. You can't control the progress through it. If you need to do something like that, then I urge you to take a look at something like Lottie or Kyrie, Kyrie drawable. So it's really good for anything which is like performance critical. And that was AVD.
Thank you. Now, physics-based animation. Who doesn't love physics, right? Physics-based animation is perfect for a highly interactive use case where you have lots of gestures going on, and you want to then carry on that momentum of the gesture into your UI to create this sense of continuity. And because when there are a lot of gestures in flight, you could then potentially interrupt the existing ongoing animation. I'm sure you've seen animations where you want the view to move from one location to the other, and then there's gesture from the users, and then as a result, the ending location would have changed. And in this case, if you use physics-based animation, that would just simply change some physics force, and then as a result, the course correction would be very smooth, and it also gives your app a more realistic look. So here I have an example of this little bubble with my cat's picture on it, and it's in a application overlay window, so it sits on top of other applications. And in this case, that is the beautiful Timely app. My goal is, as I drag this little bubble around, I want it to follow my finger, and then when I let go, it should rest on either side of the screen. So to achieve this, we obviously need to start with an untouched listener, and then we're going to use the velocity tracker to track the movement, and then when there's action down, we need to record a bunch of positions. And in the subsequent move events, we're going to need to calculate how much it has moved, your finger has moved since that down event, and then update the bubble's position accordingly. And then when there's action up, that's where the interesting bits come in. We're going to calculate the velocity from the velocity tracker, and then here for simplification for the demo, we're just going to say when the velocity is greater than 0, we're going to just move to the right side of the screen, otherwise left side. Now that we have the final position where we want the bubble to rest on, we can create a spring animation to animate that bubble's param x prop. That is a custom property, which I'll explain in the next slide. Now before we start the animation, we also want to set the start velocity. And this is critical to ensure that that transition from gesture to the animation is seamless. So this is my custom property, and the whole point of this custom property is really just to associate the animation value with the position of that bubble. Whenever the animation value changes, we get this set value call. We're then going to set that animation value onto the layout params.x, because the view is animating in a application overlay window. And then we're going to have the window manager update view layout to reflect the change. And then similarly, in getValue, we're just going to return the layout params.x.
Back to me. Thank you. Next up is the Transitions API. Now, transitions are really about looking at two different layout states and saying what has changed between them and how do I create an animation to animate those changes. So really, you can think of transitions as like a factory for creating animators based on those two inputs. A while ago, I might have stood up here and talked about how it's great for doing things like this, where you can have two different constraint sets and using Transition Manager. But I think that this use case is actually better solved by MotionLayout, so I wouldn't consider this a good use anymore. It does still have some good things going for it. In particular, this is probably one of my absolute favorite Android APIs. Transition Manager Begin Delayed Transition. It's like deceptively simple, but you call this, and then you make some changes to the view hierarchy, and magic happens. And that magic is exactly what we just talked about. It looks at those two different states of the UI, works out what's changed, creates an animator, runs those animations. So simple. There's also an overlay where you can control those transitions. The other thing I really love about transitions is that what it does to the shape of your code base. So for example, here's a change where I moved a bunch of code out of the view layer into transitions. So when you're doing animation, sometimes your code can look a bit gnarly like this. So you're doing a lot of view lookup stuff, adding pre-draw listeners, and like poking around at the view hierarchy. By moving it to transitions, we end up moving it to this much more kind of like declarative, composable architecture. So here I'm using some custom transitions I wrote, as well as composed with some of the framework transitions in order to achieve the same behavior, but in this more composable manner. So yes, you might have to write some transitions yourself. Like, so here's one I have to write to do a circular reveal. But that code ends up being much more, I don't know, like nicer to work with and much more focused. And I found it like a really good change to the code base. So transitions, when should you use them? Like for me, there's actually one really strong use case, which is shared element transitions between activities or fragments. So it's pretty much the only thing you can use to achieve this, unless you go like super custom. That is the use case for transitions. There's actually two transitions going on here. There's the shared element, which is between the two activities we see here. And then once the details activity launches, there's actually a window content transition, which is when the window launches or when it exits, run this transition, run these animations on the content. So when you see it come in here, when the view arrives, the rest of the content animates upwards. That's a window content transition. So when should you use Transition API? So shared elements for me is a really, really strong use case. Window content and enter and exit. Also, if you're really looking to like modularize and compose your animation code, then transitions can be really helpful, as well as simple changes using that begin delayed method. So yeah, transitions definitely still have a use case. MotionLayout.
All right, so far we've been talking a lot about coding, right? And the nice thing with coding is that it's super powerful. You can do a lot of things. The APIs are really, really complete. On the other hand, it's also quite time-consuming. So, taking my hat on the Android Studio Design Tools team, what can we do to help that? Really, our goal is to make you more productive, let you iterate faster, experiment, and make your life easier, really. So we want to make, particularly for motion, we want to make the motion design a lot more accessible. So one thing that we introduced recently in ConstraintLayout 2 is the helpers objects. And in fact, helpers object is something that you've been using if you use ConstraintLayout before. That's what we use for guidelines, for barriers, for this kind of tools that are not really part of your view hierarchy in the sense that they don't show up on screen, but they are here to help you create those layouts, so to basically bring additional concepts to make it easier. And in 2.0, we expose them publicly, so you can yourself create helpers just by inheriting the class. And what's great is that it's a way of encapsulating a behavior in code and putting into a helper. We support the use of helpers in Android Studio, so it's very easy to add widgets to those helpers, to have the helpers reference those widgets, and you can think about it as a way of tagging those widgets with a specific behavior. So in the case of animation, that's really nice because you get the code, you had your helper built on top of this code, and we got all the wealth of the Android animation APIs, and you can do stuff like that, right? So for example, circular reveal. Pretty well-known animation. The only thing I really needed to do here is to define this piece of code. And really, what I'm talking about, yeah, okay. What I only need to do here is this code that you see on the screen. I'm simply calling the view animation utils create circular reveal. So I'm not reinventing the wheel here. I'm not coming up with my new way of doing circular reveal. But that's the only thing I need to do for my helper. And then in your layout file, you only need to declare that helper and specify the IDs of the widgets you want to apply to. So it makes basically it's a lot easier for you to package blocks of reusable code and use them in your application. So going back to the code stuff. So the other way that we thought about making your life easier, beyond letting you build those reusable bricks, is by moving to a declarative way for animation. So you can think about it as a specification for motion, and we interpret this specification with a motion engine. And on top of that, we are building a graphical motion editor. So it's something we introduced at Google I/O. We are still working on it. We decided to focus those last few months on the library side that implement this motion engine, because we kind of want to make sure that it's right for you and for your needs. But just a quick overview on the current build. It's coming along, and hopefully it will come soon in a canary version of Android Studio. But essentially, we want to make sure that the concept in the libraries are right before kind of releasing the tool. So that's kind of like the overall approach we have for helping you. So the helpers on one hand, and this motion specification on the other. The thing that's kind of nice, if I look at this in particular, is that you can specify this motion, and we'll then take care of it. You don't really have to write code for it. It's really completely declarative. So the one way right now that we implemented this motion spec is through MotionLayout. So what is MotionLayout? It's a view group. So one caveat is that it means you can only animate the children of that view group. And it's a subclass of ConstraintLayout. So if you know ConstraintLayout, it's great. You can directly use MotionLayout to animate your existing constraint layouts. On the flip side, you do have to know how to use ConstraintLayout. But it does a lot. So we do layout transitions. We interpolate properties as well. We have a really powerful support for touch-driven motion. So it's kind of like taking a little bit of various areas of animation and packaging it into a single place. So roughly speaking, the only thing you have to understand is we are animating between two states. We have a start state and an end state. And we just interpolate between those two things. So in addition to basically supporting layout changes, so essentially if we have two versions of the layout or to go from one to another, we also support custom properties. So for example, if you want to animate colors, and we also support the concept of keyframes. And you can think about keyframe as essentially a modifier on that transform between the start and the end. So to kind of summarize, with MotionLayout, it allows you to think about your animation, your transition, your motion as a declaration. You just specify what it should do, and we take care of it. It specifically is great when you want to do fine-tuned animation, what we call like bespoke animation, bespoke motion. So where it's very specific what you want to do. It's about like coordinating a bunch of widgets together in a very specific way. And finally, it's really nice as well for the touch-driven motion.
I don't think I need the mic.
Go for it.
Yeah. So I want to just kind of like show you guys a lot of things, and it'll be a little more visual from here on in. So this is where you want to create carefully crafted, custom, coordinated, crazy cool animation. You can do stuff like that. So how did we do that? It's just two chains that change into one chain, and each letter is a view. And then we use a stagger and a color change in a custom attribute. It's fairly simple to build. It took me a few minutes, and it looks cool. And that's kind of what this stuff is all about. So the first thing, you can drive our stuff with touch. Essentially, it will handle swipes. If you flick, it will go across quickly. It understands the velocity and manages that. The next thing to understand is we're starting from 2 constraint sets, but we have keyframes. And in this case here, I'm starting with 2 constraint sets, and I'm not having any keyframes. And you see how it crosses right there. Right there, they overlap. So what you do is you add some key position keyframes, and you accelerate in the X. You finish the X part of the motion halfway through. And that gives you a kind of smooth, you've seen this. It's your settings menu. So on the more extreme end of what we can do with keyframes are key cycles. And here you can see a bunch of different kind of effects that we can do. Essentially, anything that's oscillating, it's shaking, or it's bouncing around, you don't want to actually go and build out complex paths with keyframes. This solves it. And then in Alpha 2, we introduced time cycles. And this is a kind of a crazy animation that you can do with it. Of course, this is way too over the top, and please don't use this in product. So let's get into how to use it.
Right. So give me that. Thank you. So first of all, there is a bunch of documentation that we created. So I'm going to pass quickly, but please look at those articles. There's also a GitHub with examples, so look at that. But one thing you may ask yourself is that, OK, this is all great, but how do I use that in my application? Do I have to restart everything from scratch? Not quite. Like, this is an example here where you have a collapsible toolbar in a coordinator layout. And to do these kind of things with the normal collapsible toolbar, it's a bit annoying. You have to do it in code, et cetera, et cetera. You can simply use a motion layout instead. So you still use coordinator layout. You don't really change anything else in your code, but the collapsible toolbar becomes a motion layout and take all the advantages of it. Similarly, if you have a drawer layout, you don't have to use the menu class. You can use a motion layout for it and do anything crazy. Same thing for view pager. You can easily plug motion layout into it. The last example is interesting. It really looks like coordinator layout, but actually, this is pure motion layout. And what's nice about it is that it actually is 2 motion layouts nested. And we have one for the collapsible toolbar. It's exactly the same one I used before for the coordinator layout example. And it's simply nested into an outer motion layout. And what's really nice is that in order to specify how this overall screen behaves, I just need to create those 2 states, the start and the end. You see that in the end, I bring up a fab, and I simply make the motion layout that's for the toolbar a little smaller. And basically, we take care of all of it. So to summarize for the current state, we are still working on the graphical editor. But for the library, we released it already at Google I/O. And since then, we did an alpha 2 with a few more properties. And even though it's in alpha, it's actually built upon ConstraintLayout 1.1. So it's actually pretty stable. And in fact, because it's pretty stable, quite a few people started to build stuff with it. And we'll go through some examples just to give you a little taste of what you can do with motion layout. So
I looked on the Twitter a lot. I checked motion layout on Twitter all the time. And I thought I would just share a few interesting animations that people have published. So most of these you can actually find in GitHubs. These people publish them as videos, and I've asked all of them to sort of show them. This guy has been doing quite a few pieces of work with it. It's kind of interesting to see what he did here.
Yeah, and this one is particularly interesting. By the way, you did not maybe notice in the previous one, there was an arc motion, which is very nice, something we did in Alpha 2. But in this particular example, what's nice is that it's kind of like a view pager. He did it in motion layout, but he also added a way to drive it from code. And that's a very interesting future avenue for us where we're going to explore it a little bit. How can you, in code, reuse some of this previously defined behavior?
So another one by him. The interesting thing here, it's sort of mixing what is a normal recycler view and then a sort of a reveal detail view. But it's an interesting motion layout-based animation between the two of them.
And you notice that it's super easy to come up with your own ways of doing this kind of transitions. You're not limited anymore.
Yeah. This guy implemented a material design animation spec, but just using motion layout and a custom view that he built. It was quite a nice piece of work, actually. One of the things I liked about this one is it's so original. I mean, you see a view pages, yeah, okay, this is like taking a whole new twist on it, or spin on it, actually. But you can see it's original, and that's the beauty of motion layout. You can sort of explore your own creativity or your team's creativity with what they like and what they do. This one is interesting because it's kind of like a typical coordinator layout stuff, but you see it's transparent, and there's some special effects going on with things fading in as it's collapsing. It sort of produces a unique, custom view of the whole thing. And this is our Chris Baines. And he did a very interesting one, and it's a whole app. It's actually, all the codes involved is out there. And it is very custom. So let's take a little closer look at it.
So what's great with it is this is the type of motion that would be kind of annoying to build purely by code, because there's a lot of subtle coordination across so many elements. The text is fading, that poster is actually rotating, but actually matching the angle of the cut. So that's what we mean when we are talking about bespoke motion or very fine-tuned, custom crafted motion. This is the type of example that we hope will encourage you to build.
As a small sneak peek at what we have in Alpha 3, it'll support multiple states and allow you to interact with the multiple states purely from touch. So this is one single motion layout, but in fact, it's handling transitions between 3 transitions, from a blank page to swiping up at the bottom, to swiping a little bit, to swiping more. It's all one page, one motion layout, and it can produce a fairly sophisticated custom view, and I sort of made it look like a dialer.
Yeah, and this entire behavior, this touch behavior, 0 code from your end. It's all declarative.
Pretty awesome. Cool. So today, well, hopefully, we've given you a guided tour through this variety of animation APIs that does exist on the platform. And our goal was really to make you more familiar with what they're good at and what they're not so good at. So I'm going to try and summarize that as a takeaway for you here so that you are confident in picking the right one at the right time. For complex coordinated layout, and especially for that nice handoff between gesture and animation, then really, really, really do check out MotionLayout. Next up, if you need to build interruptible animations, or again, do gesture to animation with like that velocity tracking, then look at the physics layout system. If you need to do shared element transitions or window content transitions in your application, then Transitions is the API for you. And if you need to do vector graphic animations, then check out Animated Vector Drawable. If you need to do window animations, and only if you need to do window animations, then the original SDK1 view animation system should be used. It's your only choice. If you need to animate properties of views and it's supported by it, then look at the view property animator. If you need to do like custom view animation or some custom thing driven just by an animation pulse, then look at the value animator. And lastly, like else, use ObjectAnimator. ObjectAnimator is your go-to default for general purpose animation. So hopefully that's made it a bit clearer. So next time you have to build something, you won't be paralyzed by choice of the different animation APIs. So thank you very much for joining us, and we'll be outside for questions or contact us online. Thanks very much.